This is the ARB Podcast, recorded October 17th, 2011. Episode 65, Dave's Dingo Dystocia.
Welcome to the Amp Hour. I'm Dave Jones from the EEVblog.
And I'm Chris Gamble from Chris Gamble's Analog Life.
Hey Chris, what's happening in good old Cleveland?
Oh, not much here, Dave. What's going on across the pond?
Oh, it's coming into summer over here, and it's going into winter over there, right?
Oh,
So
yeah.
you're thinking about retreating out of the basement.
That's right, yeah. I'm thinking about taking refuge in a warmer location known as upstairs.
Right.
Yeah, I was saying to Dave before the show that, we used to have these show. We used to take even longer to record before because we had even less clue of what we were doing. And at the end of the show, I'd be like, Dave, I can't do it anymore. I can't feel my fingers. I gotta go upstairs.
It never gets that cold here.
Yeah, that's nice.
Never got to the stage.
It does here. It does.
Right. Okay. Where it's actually snowing. It's never
Right.
snowed here in Sydney, as long as I've been.
Yeah.
Here anyway, so it does snow up in the mountains, once a year you might get, a little bit of snow, and it's rather exciting. People flock up there just for the novelty value.
Yeah.
Yeah.
Well, that's good, man. It's nice it doesn't get that cold.
No. Coming into summer, I love it. It'll be canyoning season again.
Oh yeah. Any plans to throw equipment? And you're gonna take a spectrum analyzer out with you this year, or maybe
I haven't got anything yet, but if anyone's
bench
got
meter?
any ideas, especially the manufacturers out there, if you got something that you think can survive a canyon trip, by all means, send it my way.
It's too bad that it would be really bad littering to have electronics components float down a waterfall.
Yeah,
you take a really old scope you just buy, it's already junked, and you just toss it off and see what happens.
Yeah. Well, everything's lead free these days, so that's not too bad.
Yeah,
so
but if you're
water
buying
gets in its circuitry,
Yeah, but if you're
That's
buying
right.
a 425, tech scope,
right, with a
that
ton
thing's
of lead in it.
It's probably got mostly lead and mercury. It's that's all it's made out of.
That's it. Oh boy. Yeah, I was going to do a waterproof multimeter shootout, but there's hardly any of them on the market. And I've already
there's not
done
really.
2 of them. I think there's one other, which is a El Cheapo J-Car one hung low brand. So that's about it.
Yeah.
It's not
You
very
should do
exciting.
maybe you could do a homebrew version where you just put it in a Ziploc bag,
A Ziploc
and then
bag,
you seal
yeah.
it up, and you see if
Right.
see if that one can survive. That would be the real test, right? See if you need to pay for that extra bit of water sealing and
waterproofness,
testing.
right?
Yeah.
Oh, you could
Or
always
you could
put it in a dry bag, but it's a bit
True.
lame.
Yeah. Or you could you could take up scuba diving and really see how far those things can go down instead of just
Right.
into a waterfall, right?
Yeah, instead of just a meter, it gets
Yeah.
plunged a meter, but most of them are only rated to, IP68, I think it is continuous immersion in water at 1 meter or something.
Okay,
So,
okay.
You take it more than that and, no.
Yeah,
It's not gonna do too
imagine.
well.
I can't imagine. I mean, I understand the waterproofing idea of it, but if you're measuring electrical signals, you probably don't want to be in water. I'm just
Yeah,
just for all the
exactly.
people
I know.
listening out there. I mean,
Yeah,
just,
you don't want to have your
don't-
probes attached and you're measuring. Stand near water up to your knees and then you might.
Yeah. Does this
You
thing
measure
measure
the
line?
mains.
Does it measure? Yeah.
Is it still Cat 4 rated?
Yeah. Right. Am I Cat 4 rated?
Oh, boy. Yeah,
Yeah.
so it's a bit silly, the waterproofness of... No, it's good for... No, I've worked in environments where meters get, dropped in drums of oil and all sorts of,
Really?
all sorts
Oof.
all
That's
sorts
horrible.
of horrible stuff and, and those sort of industrial environments, your meters get the crap beat out of them. So it's not actually the waterproofness itself, because you don't actually operate the damn thing underwater. I mean, that's just, stupid. But the fact that it's fully sealed and nothing gets in, no dust, no chemicals, no, so that if it does get dunked or splashed on or something, you just wipe it off and it's fine, and it
Right.
survives and it's still within cowl and everything's hunky-dory.
And it's just harder to hold now.
Yeah, exactly, because it's all slippery, it's covered in oil. Oh, boy.
Well, you had a
Yes.
bit of news, didn't you?
Yes, there is some news. There's breaking news just out today. It's the 18th here in Sydney, which is good enough for me because I wasn't told otherwise. So,
Dave needs express gag orders, really, when he's told these leading-edge things, but our audience isn't big enough for it to really matter. By the time it really propagates, it's probably fine.
It propagates through, which reminds us, yes, we had the servers choking now, isn't it?
Oh, yeah.
It's absolutely sorry for everyone who couldn't download last week's episode because the server just can't handle. I'm not sure why all of a sudden. I mean, have we suddenly gained an extra 1,000 viewers or something?
I doubt that.
In a week? No. So why is it suddenly just fallen over? And everyone's getting stream rates of like 0.1 kilobytes per second.
That's what I got. It was horrible. I tried downloading our own episode. It was like 6 hours. If you wait.
It took me like 5 hours to download it so that then I could upload it to my own server.
Yeah. Oh, that's horrible.
Oh, man. It was horrible. So, sorry, we have no idea what's going on there.
We're going to post from Dave's server for now.
Measure, we're putting the MP... The website's still on the shared server, but the MP3 is now going on my new server, which is completely dedicated, and hopefully it doesn't choke the forum. So if you're a forum member, and as soon as this upload goes up, please tell us if it affects the forum at all. I'd like to know, because if if my dedicated server can handle, streaming audio and the forum and the blogs and everything else, then great. But if not, we don't know what we're going to do.
Yeah, we'll probably buy some other space. So sorry about that. We'll post a link to the EEVblog forum. There's a thread on that, so if people have problems, they can just post in there, and that should be a good place to capture info. So we appreciate all the people troubleshooting for us.
Yes. And that's the other place you can leave feedback, is on the forum as well as the site as well. So if you want to chat to other people about the amp hour, the forum's the place to do it.
Feel free to take some pot shots at us, right?
For sure.
Yeah.
I'm used to it. Get it all the time.
Yeah, exactly.
It's fine. Back to the news.
Hit it.
Agilent. I'm going to claim credit for this one.
Okay.
Damn right I am. Because back when I reviewed the Agilent 3000 series scope, one of the big features was that it came with a function generator built in. Fantastic. But I complained that there was no arbitrary waveform capability. And Agilent at the time said, we considered it, but we didn't want to do it because then it would ruin our, the guys from the function generator division didn't want it because it would ruin their market. Yada, yada, yada. And sure enough, what is it, 9 months later or something? They have released new firmware today for the 3000 series, and it's got a whole bunch of new things. It's codenamed. They've got a code name for it. It's codenamed Dingo. So
really?
Yeah.
See, there's
Dingo.
There's even more proof right there.
So it's codenamed Dingo, and it's released today, October 18th. You should presumably be able to download it. I've got an advanced copy of it, which I've installed. And I've had a play around with. I'll probably shoot a blog today on it, actually.
Cool.
To show people what it can do. Left that a bit late, didn't I? Oops. It's free. You can download the new firmware, and it's got arbitrary waveform capability built in. Ta-da!
So, Dave, what you're saying is you impregnated the Agilent with this idea 9 months ago, and now they've birthed out an ARB baby. Is that what I'm hearing?
That's pretty much, yep. You're right on the money. I'm going to claim credit for it. It's my baby.
It's Dave's baby. That's right. It's an ARB baby.
Anyway, so I'm rather surprised, actually, that they did do it, because I don't see, I thought they might do it if they got pressure from, another manufacturer came out with a scope that had, a built-in function gen and it had ARB capability, then, Agilent might up the ante and do that, because the architecture inside was always capable of it. In fact, it basically did have an ARB Gen in there. It's got 8K of sample memory or something, and it was all built in. That's how it generates its internal waveforms, is actually in an arbitrary type manner. That's why I can have all these different waveforms. But it just wasn't software the software wasn't there to enable you to save and edit the waveforms and stuff like that, but now it is. And it's cool. You can actually edit the waveform on the screen, and it really seems to work quite well. So
now Dave's gushing over his child. All right, save it for your video, Dave.
Right. Okay. Anyway, there you go. Yeah, they've released new, they've added new software modules as well. Like
oh, and look at the little baby, and oh, look at the dimples in his cheeks.
You'll like this power supply analysis module. Is really cool.
That's cool.
And I love these new scopes. Like they pop up on the screen when you go into the power supply module. It pops up with the connection diagram of how you should hook it up to your, here's your DC to DC converter. Here's your current probe on the input. You should put the current probe to channel 1, the voltage probe here, and the output, And it's a little diagram to show you how to set it up. It's great. You don't have to read the manual or think about it or... it's good.
Yes, let's not think about it. That's the important
let's
thing.
not think about it. Let's just do it by But it's just nice to help you. If you haven't done that for 5 years or something, you're gonna have to put your thinking cap on and But there it is. It's all there. It tells you how to hook it up and how how it works with it because you're not sure, how the software wants things interpreted and probed and stuff like that. So,
cool.
It's fairly important to have that sort of thing. So it does that. I like it.
All right.
But that's not free, I don't think, the software module. So don't get excited there, folks. But the ARB capability, download it, install it if you've got a 3000 scope.
Anything else? Do you want to tell me how it's going to grow up to be a big soccer player or how it's going to be a concert pianist, Dave, or anything else like that?
No. I'll tell you my next idea, though.
No.
Come on. Can I impregnate them again?
Oh, okay. Yeah, this will be an interesting thesis here.
The other thing I've been complaining about is that the function gen doesn't have external modulation capability. Whereas I'm wondering, does the architecture inside support the capability of using one of your analog channels as the modulation input? That'd be cool.
Cool. That would be cool.
That would be cool. Can it do it in real time? Can it sample that analog input and feed that through and modulate the ARB function capability? I don't know.
Yeah, that'd be a cool idea.
That'd be nice.
Yeah, definitely.
Because the bastards didn't put a external modulation BNC on the back, so
yeah, like most function generators have.
Yeah, exactly.
Yeah. Well, that could be cool. All right, we'll see. Maybe it'll be Dingo Jr. 9 more months.
Right. Dingo's got my baby. That's an Australian joke. Sorry.
Yeah. No, it's
most Americans know that, I think.
Yeah, that's they talk about that in Seinfeld. I think that's how that got big around here.
Oh, really?
Back in the
Okay.
day.
As everything in the US in the 80s and 90s got big,
90s,
right? Through
yeah,
Seinfeld.
yeah.
Was it 90s?
Yep.
No, Seinfeld was 90s, right?
It was 90s. Cheers was the 80s. That's what you're
Right,
thinking
Cheers,
of.
yeah. Right.
Yeah. Got it. Pop culture. It's important, people. All right, let's get some shout-outs. Shout-outs. How about first shout-out? How about that third one on there, Dave? That's my favorite one.
Oh, Chris.
It's us.
It's us. Yes.
Both of us.
Well, a shout-out is usually to us because we give you a shout-out if you mention us. Usually. That's how it works, right?
Well, there's that, but this is actually us. This is actually us talking about us now. Talking about us. So we were on Zombie
sorry.
Tech.
Oh, I thought you meant the EEWeb thing. No, yes. We're on another podcast.
Yeah, we were both individually. I was on last week on Zombie Tech, which is by Toy Makers, and Dave was just on yesterday.
Yes, I was. I recorded it yesterday, and it was cool, and it comes out Thursday, so you've got to wait for it.
Yeah,
Unfortunately,
a couple days.
Yeah.
But you can
go straight away.
You can go listen to me right now. It was fun. It was a lot of fun talking about it. It was, it branched out more. They talk about and we've talked about that on here before, but they talk about technology as it relates to zombie apocalypse just as a conversation starter. Yep. Although I don't know, Addie might actually be kind of worried about zombies.
I think she's genuinely concerned. Yeah. We talked about it fairly extensively.
Yeah.
Given my limited zombie geek experience, which is zero.
Right.
Yeah.
Yeah, it's a fun premise, though. I mean, it gets people moving on ideas. So I talked about a lot of stuff I don't think you and I have ever talked about on here, so it was cool.
Excellent. I think mine was just an hour of absolute
Blather. I love that word.
It is pretty good, blather. So I don't even remember what I talked about. I have no idea. Sorry.
Yeah.
I don't think
That's
it's
okay.
that technical.
Okay.
Could be. I don't know. No, they asked me lots of questions about the show and stuff like that. So
Cool.
Yep.
But there are the traditional shout-outs we have as well. Eric, the embedded guy who we've talked about because he won that touchstone contest and everything else, he actually was in the Pulse magazine, which we talked about last week, which is by EEWeb, and he mentioned, I actually just saw someone clicking through from that thing, from the online version. So he mentioned the amp hour. And so thanks, Eric. That was
Cool.
That was cool to see it in print. I've actually never seen the actual print version.
I was going to say, yeah. It's electronic print, right?
Yeah. Put on my e-reader.
Right.
Yeah. And let's see.
one more shout-out.
Yeah, go ahead.
Well, you're the one who put it in here.
Oh, okay. Well, it was Dennis Machida. He runs the Garage Engineer, is his blog, and he just wrote about the amp hour, and he just started up a site a couple months ago, and so he linked here from there, and he's got some great content on there already, just about the stuff he's learning. He's teaching himself engineering, basically. So, Right on. It's awesome. So
Excellent.
Thank
And
you
he's
for
got a
linking it.
photo of himself on there. I love that. I love when people put a photo of themselves. Smiling, waving. There we go. Fantastic. Good on you. I hate, blogs who just, you got some blurry little stupid photo, if anything. It's just, I don't like it.
Yeah.
So, I like it when people put a nice photo up there. You can see who's running the blog. It's great. Good on you, Dennis.
Yeah, that's great. And then one last one that was going to be a shout-out, but actually I decided is a rant.
Okay. Rant away.
So Ben Rampling, who's wrote in here before, he started a subreddit. So if people don't know, this show started because of Reddit. Me and Dave were both on one of the subreddits at a time, which is just like a message board, basically, talking back and forth. And that's how me and Dave started the show. And so I'm a very big fan of Reddit. Dave used to be a big fan of Reddit. I don't know if you're
I haven't looked at it for a long time. So, I got into it a bit at one stage. But, it's sort of novelty wore off. Sorry.
Yeah. Oh, that's okay. And basically, though, Ben started up a thing called Nice Chips. That's the subreddit's called, is Nice Chips. And we'll put that in the show notes. But basically, it's 24/7 chip of the week. And now, how the hell are we going to find a chip that isn't mentioned on this site now? It's like, what? You're killing me, Ben. You're killing me. So, it's...
Well, I'll tell you how. Because if you go to DigiKey, there's about 100,000 chips out there.
Yeah, I know.
Unless they plan on covering a lot of content, then...
Yeah, that's true. There are a lot out there, but... it's cool. I mean, the ones that are already on there are pretty good. And it's nice because you can set up commentary and talk to other people about it, and even link in app notes and stuff like that if you're so inclined. But mostly, it's just about finding. That's always the hard part is finding out about new chips, and it's hard to do. But there's some good ones on here, and some that I had never heard of. So,
how do you start a new Reddit category?
So if you're looking at a Reddit page, on the right-hand column, there's a create your own community.
Oh, right. Okay. Oh, there you go.
I'm predicting Dave's going to start within the next 4 minutes.
You could be right.
Yeah. It's not hard to create one. It's hard to maintain one, It's
right. And build up an audience in there and get people.
Yeah, not even an audience.
And...
It's just it'd be like spreading out the EEVblog forum if you really wanted to, but I don't know. It's hard. It's hard to. It's not an easy thing to do to keep people engaged like that. So it's if you can. I hope this Nice Chips thing works because it's a great idea for a subreddit. There's ECE, which is electrical and computer engineering, and then electronics, and I'm a member of those, and I like them both. So I don't know. Hope people do the chips thing because then we can snag one or two for chip of the week. We'll still try to find new ones, but it's tough. So that's it for the shout-outs, Dave. That's all I got.
That's all you got. You're out.
It's only
all right.
4. Yeah.
We'll have to move on to something else.
Yeah. You pick, man. It's up to you. We got a lot this week.
Well, we can talk about ADCs. First cab off the rank. Everyone likes ADCs.
That's lazy.
Why? Everyone loves ADCs.
Everyone does love ADCs. This was an electronic design article I saw a couple weeks back. Basically talking about the difference, though, between like a precision ADC and an audio one. And how, you know, if you can use audio and like a high precision, because you see like 24 bits. Okay, that would be great. I want 24 bits in my measurement,
and it's $2, you know, and it's
exactly. It's like, this is cheap.
Why wouldn't you use it?
Yeah, and it's got a lot of
other
good
reasons. It's because they're shit for precision applications. That's why they have audio ADCs and they have precision ADCs, even though they're both 24 bits and they're both.
Yeah, and then the 24-bit
both
one,
the same architecture.
The precision one is like, like $30 or something like that. Probably not $30. You can probably get a 24-bit for, depending on how fast it is, I guess. Because that's the real thing that trades off then, too.
Well, I used to use a $100 ADC.
Really?
Yeah.
What was that for?
That was for my towed array seismic stuff. So we would have 10,000 channels of these things, and each channel was $100 US.
Good God.
I'm not kidding.
No, I believe it. That's crazy.
That's how high-end these chips were. High-end, specialized, you know. Each one individually manufactured by nude virgins, you know.
I don't know about that one. I'm going to stop there in the believing. But
right.
And so you use precision, though?
No. We used audio. Seismic ones in particular.
So real good low-frequency characteristics and stuff like that?
They only go to like 4 kilohertz bandwidth. They can't even do audio. But their THD is phenomenal. You know, leading edge, you know. You can't even touch them. And the other thing is extremely low power as well. So extremely low power for a given bandwidth. Because the problem in the seismic industry is that when you've got 10,000 channels towed behind a boat, these things have to be buoyant. They've got to float. So when you've got, and they're about 10 kilometers long. What's that in feet?
Oh, I have no idea.
What's 10 kilometers in feet? It's 30,000 feet, right? These things can be up to 30,000 feet long, towed behind these seismic boats. They've got to float in the water. So there's a huge trade-off between the amount of buoyancy material you need versus the power. You start out with the power consumption of the ADC. This is why it's so critical. When you add up 10,000 channels, that, you know,
that's a lot of channels.
Each little microwatt counts. Yeah, it's a lot of channels, right?
And what year was this?
Counts. Oh, this was 90s.
90s?
No, sorry. 90s to 2000s.
Okay.
Mid 2000s, 6 years ago was the last time I worked on it.
See, because it feels like there's been a big not upheaval, but like a lot of strides taken in the past 10 years. Just looking back, obviously, I wasn't using precision ADCs in the past, 10 years ago, but it seems like they move really fast, and now they're kind of starting to reach a threshold of specs. I don't know. Maybe I'm wrong, but it just seems that way.
There's a limit to how good you can make them. There are, it's sort of just tweaking around the edges.
Yeah. Well, we should explain the difference, though, between audio and precision. I mean,
hang on. I haven't finished my story.
Oh, whoa, okay. Jeez. Throw your 10,000 channels back in the water,
right,
Mr. Jones.
10,000 channels, right? So each one of those takes X amount of power, right? If you just ignore the other circuitry, you just look at the ADC itself, right? If it uses an extra microwatt or whatever, then the power consumption adds up. And over that, you've got to get the power to those modules that can be up to 10 kilometers out in the ocean along one cable, right? So the more power you take along that chain, the thicker your copper has to be to get all this power 10 kilometers down, and the higher the voltage, because they would typically start at 400 or 500 volts at the boat end, and by the time it gets to the other end, it's like 60 volts or something because of the huge drop along the cable. And so the more copper's heavy, right? So you've got to.
So they need more buoyant material,
right?
Yeah.
The greater the copper, the more buoyancy material you have to surround it, so it's neutrally buoyant, so the thing can, not just float. Well, actually be buoyant, not actually float, but just balance so it's buoyant. And then the more copper you have, the more buoyancy material, so the greater the diameter of these streamer cables are, and the greater the diameter, the bigger the drums have to be on the back of the boat to store them when you winch them in and wind them up, and And there's only so much, so that limits the length because you need bigger drums. So it's all a massive trade-off.
So
it's awesome. I love it.
Total harmonic distortion and money versus drum
everything.
size.
Versus drum size on the back of the boat. And
that'd be a fun graph to see, right? I mean,
there are graphs until the cows come home. Yep. And
there's graphs for cows coming home. It's crazy.
Yes, there is. And just trying to model the power system. Like, I had to model the power system over 10 kilometres, and it's just, it's just
good God.
Yeah.
Yeah.
The complexities involved are just stupid. Anyway, so there you go. Power matters, folks, when you talk about a shitload of channels like that in some bizarre application.
That is a bizarre application.
Yeah, it is. And that's why they cost $100 each.
See, now I've used ADDs mostly in the precision sense. And so I'm the one paying.
You were going to mention the difference between precision and...
Right, yeah. And so one of the big things is DC accuracy. That's a big deal, especially when you look at like these really fast ones, because that's where a lot of the leading edge is. They're like, oh, this is 1.2 gigasamples per second, that kind of thing. And you're like, oh, well, can it measure a volt?
Accurately. That is
for more
actually
than
the definition
sample?
Of a precision analog to digital converter, is that it's accurate at DC.
Yeah.
That is basically the definition.
Right.
That's the difference between an audio ADC and a precision ADC.
Right, and down there it's harder to do it. I mean, measuring down, not hard. It's a different problem, obviously.
And it's got to be monotonic, and it's got to be
right, yeah, and linears and other things
linear,
too.
And it's
missing codes and all that other crap.
Yep.
And in fact, if people are interested in this kind of stuff, I mean, Bonnie Baker, I always point people to her article. She has tons. She works at TI. She's got tons of great articles on ADCs. I think she's into doing some other stuff and writes about other stuff now. But I always love her Baker's Dozen articles. I don't know if they're still published, but she was...
Yeah, I used to read those back in the day.
Same level as like Jim Williams and Bob Peace kind of stuff, so it's great.
Yep.
So I'll see if I can link some stuff in there for that. But yeah, it's interesting. So the answer is really, you can use them.
Depends on your application.
Yeah, you can use them, but don't expect. Don't be surprised when your measurement looks like crap if you're trying to measure something precisely.
Like you're trying to measure a bridge. You're trying to measure a strain gauge or something like that. You can't use an audio ADC, even though it is a 24-bit delta sigma, exactly the same as this other 24-bit delta sigma, which is classed as a precision ADC to measure like a strain gauge, which is a DC thing, it's a bridge, it's a resistor bridge. Yeah. It's a bridge, and to measure that, you need a precision ADC, not an audio. Even though they're both 24-bit delta sigma, the difference is one works at DC and is accurate and all that sort of shit, and the other is just good at the dynamic stuff, the THD and the signal to noise ratio and all that sort of thing.
Yeah.
So, but when you're measuring a bridge like that, all you care about, you don't care about the THD, you care about the bloody, the gain and the offset errors and that sort of stuff. All that precision, in quote marks, stuff. So there you go. Yeah. There are differences.
Definitely.
So if you're going for a job and and they ask you about ADCs, there you go. You can tell them all about the difference between precision ADCs and audio ADCs.
Yeah, and did you happen to see... So the ADCs, I mean, the packages aren't too weird on those, but did you happen to see those pictures I posted this week about packaging? I met with a vendor this week, and he showed me some of the new packaging, and it's not that new. I mean, it's just new. It's new to me. I know that. But my God, it is just like unbelievably small. I took some pictures. I don't know if we can see them, but...
I've got a picture here. You've got some SOD packages, some SOD 923 and SOD 523 and stuff like that. Yeah.
I think all the dimensions are millimeters, right?
Millimeters, metric. Yeah, that difficult metric stuff,
it's not that bad down there. But like the SOD 882L, right? That's the one I'm looking at. I don't even know if these are
how many pin is that package, though? How many?
That's a 2-pin.
Right.
So I know, that's just a diode or something, but that's... 1.05 by 0.65 by 0.4 millimeters.
That's huge.
It's like
that's a whole millimeter, dude.
In the lengthwise
a whole millimeter
direction.
in length. Come on.
How big are these packages that you're using? I mean, it's ridiculous.
But that's only a 2-terminal device, you know.
I
It's
know,
not,
but then there's the other ones too.
Well, we've bitched about the 0.4mm pitch BGAs on here before, you know. It's just...
Yeah, but these are, like, you could put, like, they're putting analog component. They're putting op amps in these things, man. They're putting switchers in. I mean, the switchers, they usually put, like, at least a tiny little thermal pad so it can squeak, like, a little tiny little bit out of there. But, man, it's crazy. I don't know. Here's a 6-pin package. It's like 1.05 by 1.05 by 0.5. That's not cool. That's a 6-pin, or it's a 5-pin package.
Yep.
That's not cool, man. I can't see
No,
that.
it's not.
I can hardly, I'll sneeze that right off the board. I feel like
that happens.
I
when
know.
you're assembling the prototype boards, you've got your parts there, and the last thing you want to do is sneeze, because you sneeze and your parts are gone. They're landed on the carpet, and that's it.
Yeah. Oh, God. That's what I never get. What was the carpet like at past jobs? Did you ever have, did you always have, like the camouflage carpet? I just feel like,
it was always blue for some reason. It was always pale blue or something like that.
Oh, that's not too bad.
Carpet,
like shag. It's just like there's no choice. There's no chance of it ever coming back.
It falls down between the fibers. It's gone. Anything below like an 0603 is probably, you might get that one back.
Yeah.
But
you're probably going to end up picking up
0402s
another 0603 that's on the floor as well, and then you'll just, that's what always happens, because there's always like that littering of just it's a part graveyard down there.
Yeah. It's like a Jim Williams style part selection bin,
Oh, yeah.
I need 100 end cap. There's got to be one down in the carpet. So start fishing around down in the carpet.
Yeah, just don't go for those ESD sensitive components, with all the...
Yeah. ESD, overrated.
Yeah. Blah, blah, blah.
Real engineers don't worry about ESD.
Yeah.
Oh, boy.
Yeah.
ESD will put hair on your chest.
Or conduct through it or something, right?
Right. Oh, boy. I love it. Yeah, I know. Packages are annoying. Got to admit.
There's another article about chips. There was a low power micro that was announced a couple weeks back. I don't know if you saw it from ST. It was so it was designed with MIT, which is pretty cool. I didn't know that they were like designing alongside, but it seems like it's going to be actually available. But let's see. It can operate down to 0.54 volts. That's ridiculous. And then
I know well, the good thing is that is actually below single cell.
What do you mean single cell?
As in like a single 1.5 volt battery. Typical, the end of life on that is 0.8. So for many years, the holy grail of low power parts was 0.8 volts, or maybe under a volt, was sort of, because then you'd use up most of the energy capacity in a single cell battery. Yeah. So you could power your device from a single cell.
So 0.8 is where, battery curve kind of comes down and like a slope.
It just drops off like a brick wall at 0.8 volts.
Right at the end, right? Yeah. Okay.
Yeah, it just drops. Yeah, totally. So you can't extract more energy out of a battery below 0.8 volts. So, and you could argue that the little bit of the area under the curve that is between 1 volt and 0.8 is, like the last 10% of the battery or something. So, it's not a problem if you only use 90% capacity of the battery. That's deemed to be good enough. So,
yeah, there's
a lot of people out there that actually design their circuitry to actually cut out. If you're powering things for batteries, you've got to have a battery cut out. You design it out at a volt per cell is
okay
a rule of thumb. But you should, in theory, go down to 0.8 if you design the battery powered circuit. Remember that. Another interview question.
There you go. I've never done battery design.
I love battery design.
It's a whole other game, really. I mean, I haven't done a lot of design, really. So let's be honest about that up
right.
front. But it's definitely a design constraint that I'm not used to. But it's a good one. I mean, it's realistic these days, at least. Although I think that the voltages are changing because of lithium ion and stuff like that, right?
Yeah.
So those
which
are
a typical cutout for a single lithium ion cell would be 3 volts.
Yeah.
Whereas if you go below that, there's
a
a little bit of energy left, but you might ruin the cell, or so generally you might cut out. It depends on the chemistry, though. The chemistry can be slightly different, whether it's lithium ion, lithium polymer, coke, or whatever anode, blah, blah, blah. So, yep, there's all these different technologies. Coke and graphite anodes are the two main types of lithium ion. Then there's a lithium polymer, and then there's various other ones, and there's more lithium ion technologies than you can poke a stick at these days. Can't even keep up.
Yeah, definitely.
But you don't want to poke a stick at a lithium ion cell. Actually, that is one of the tests. If you read,
really?
Here's a little aside.
Poke it?
Yeah, there's actually a defined test for this. They actually get a nail and you put the nail through the battery. They define, like a 5mm nail through the cell, and it's designed not to explode. They'll actually say that in the data sheets, that you can actually get a hammer and a nail and puncture this cell and it won't, it won't blow up on you. So
what happens if it does?
Well, if it does, it doesn't.
Is it like
some of them do, right?
Is that like a monster explosion or like a little explosion?
Well, it can be. You've seen some of those horror videos of laptops catching on fire, right?
I don't think I don't. Do I want to see these? I don't think I have.
Oh, they're great. Yeah, don't you like seeing a laptop burn up in smoke?
Well, no one gets hurt. Do they get hurt or no?
Oh, no, people don't get hurt. No, it's usually, it doesn't explode, but it'll heat up and catch on fire and burst into flames and that, so it won't explode in your face,
I do remember...
oh my God, my laptop exploded! Oh.
I do remember there was one story a while back about this unfortunate Japanese man who had a Sony laptop, and it was on his lap, and it kind of burns junk.
No.
Yeah. I remember reading about that, and I was a little scared to have a laptop at that point. I don't know if it was tonight at 11, is your junk getting burned by your laptop? But it wasn't the local, that's the local news scare kind of thing. But yeah. I mean, it was
exothermic reactions are a real
scary,
bitch,
I gotta say. Yeah, I mean...
Yes, that's called exothermic, folks. Yes, that can ruin your day.
Yeah.
Anyway, there are data sheets. Some manufacturers will claim that their cell, you can puncture it with a nail, and they will define the size of the nail that you can puncture this damn thing with, and,
Really? It's like isospect or something?
I think there is a spec for puncture tests. I don't quote me on that, but I think there might be.
Wow. That's pretty crazy. Yep. Well, speaking of batteries and big old batteries, have you? There was an article in New York Times yesterday maybe. Basically, people are hacking their cars now, and I didn't actually post that link there. I'll put the link in there. But the Nissan Leaf, people are hacking.
Nissan.
Huh?
Nissan.
Nissan?
Yeah, that's how we say it here in Australia. Nissan.
That's
not Nissan.
Nissan.
No, we say it Nissan. It's Nissan, mate.
I think the Japanese would have something to say to you about that.
I don't care. This is Australia. Once it comes here, we can call it anything we damn well like.
Okay. Well, the Nissan Leaf. Crap. I forgot to post the link for you. Basically, though, they're reverse engineering. It's like all these retired guys, and there's clubs now, and they're reverse engineering it because the battery gauge speaking of batteries, the battery gauge only gives you 12 bars, so you don't have enough resolution on the
that's
measurement.
Pretty shit. Yep.
Yeah, exactly. And
and is it like a proper energy gauge, or is it just like some lame ass voltage gauge they whacked in there? Is it just like an LM3914 or something?
I don't know what it is. I mean, it's not accurate.
Because if it's a true charge, if it's one of these charge gauge ICs that actually truly measures the charge going into the battery and then the charge coming out, they're 100% accurate. So 12 gauges, 12 bars would be good enough, especially if it's modelled based on the discharge characteristic curve of if the algorithm takes into account the discharge curve and stuff like that. So it can be accurate. It can be good enough, but I guess it's not if they're willing to try and hack it.
Well, I think people would be doing that either way, right?
We want a 0 to 100% display, right? That's probably what they're after.
Yeah. Well, and they're doing other stuff though too. I mean, it's not just the battery gauge. The guy is also he's reworking like the cabling. Apparently, you have to buy like a $8,000 charger station, like or $5,000 to get the fast charge. And then he's like, well,
right,
no, this is just kind of it's already good enough. You know, all cables are rated to 250, so he just kind of hacked it in there and he tested it out and he said it's fine. So. I don't know. I think it's a cool idea, but I don't think that Nissan can officially I don't think they can officially like it because
no way, not a chance
because of the safety implications. But I mean, I like it.
Well, no, because they're mucking around with serious shit there, right? That's a serious battery pack that can ruin your day. You know, if you screw around with that, right?
Yeah.
You know, you actually drive along, your car catches on fire, you know, and blows up. And,
so they're not allowed to officially, and they say that that's the thing with most cars. You know, that's the problem. Like an open ecosystem in a car would be really cool. You know, like to be able to look at the engine computer and try and tweak parameters.
See, but you can do that because that's just sucking out data. So it's easy to design in an interface that is idiot-proof, you know. Yeah, if it's just an interface that just outputs data from the engine computer, then they can design that in, no problems.
No, but I mean actually tweak the ROM and like that's the thing. You always have to.
Right. Well, yeah. Well, no, that's silly, you know, because these well, no, they probably have separate computers to control, you know, all sorts of various aspects of If you know, I mean, you know, like you don't want to muck around with something that you know is working on your anti-lock braking system or something.
Well,
you know?
yeah, but some people would, right? I mean, some people would say, "Well, I can do that better
if the capability was there."
I don't want to be in that car personally, but
no,
I mean, some people will say that. You know, they want to say that, and they want, and then, but. I mean, they are opening up other systems. Like we talked about Bug Labs last week when we were talking about open source hardware, but and they're like working on the info side, I think, you know, like in the display side, but they're not in the engine computer. Like that's an optimized. People would want to get into that though for either fuel economy. They want to try and you know mess with that, or you know charging in this case because it's an electric car, or some people want performance and all that other junk. Yeah. But I don't think they want to open that up to consumers. Even though it will only be 0.1% that actually would touch it, right? Or if even that.
Oh, not even, yeah.
I will not be. For the record, don't worry about me, Nissan. I'm fine.
Nissan.
I will be okay. You can't get over that, huh? It's Nissan.
I can't get... Nah, it's Nissan, mate.
Nissan. Yeah. All right. Anyone that speaks Japanese out there, you can confirm. I'm probably saying it wrong too, but I'm sure I'm closer than Dave is.
Probably, but I don't give a shit.
I took 3 semesters of Japanese in college. I know a little bit. I used to know.
Yeah, but you don't speak Australian,
bit.
Mate. So
I don't speak. Right. That's what I meant to say. I couldn't
find
a teacher
right
that would teach me that. They were all at the pub.
Oh boy.
Yeah.
Anyway, we have there's a new chip on the market. It's kind of new. Well, no, it's probably not news because I don't think it's new. In fact, I'm pretty darn sure it's not. But if I pronounce this company's name correctly, Silego?
Siligo? I would say Sil because like it's probably like silicon, right?
Silicon. And Sil-Ego. So
Sil-Ego, yeah. Sil-Ego.
Sil-Ego or Silly Ego. There you go.
Yeah.
That'll probably be their nickname forevermore. Silly Ego.
Because they mess something up, right?
Right. Anyway, what they've come out with is a little 8-pin FPGA, like a little micro FPGA kind of thing, but it's got analog stuff on there as well. And one of the amazing things is that they cost like 23 cents each, and that's for the high-end one. I think the low-end one is like 18 cents, wow. and that's not like 1,000 of quantity. That's 100 quantity, right? So that's $23 for 100 of these chips.
One-time programmable. You should mention that.
They're one-time. Yeah, there's always a catch, folks. I'm glad you asked. Yes, they are one-time programmable. OTP.
Yeah. That's
which
a cool
is something
idea.
I haven't heard in a while. You know, nobody does OTP anymore.
I know, right? We need those UV erasable, right?
Yeah, it's so 1990s. You know, OTP. Yeah. But it's great because they claim. I don't see it on the website, but people on the forum where I found this has claim that they've come out with some sort of press release, or they mentioned somewhere that they have sold 100 million of these
23
devices.
cents a piece. I mean, why not, right?
Well, and they design into these, all these high volume consumer. So here's a company that you never heard of, and they've sold 100 million of these.
Yeah, that's cool.
That is freaking awesome. And they've got like a cheap dev kit for like $50 that comes with like a 50 chips or something. So it's a USB programmable.
We're giving these away down here.
Giving them away,
it's like one of those car commercials.
I'm glad you asked. Yeah, I think the postage is like another $50.
Is it really?
Something. So somebody
that's
complained
shady.
that they
that's
tried
like
to order
as
it.
seen on TV crap right there.
Yeah, exactly. Right. So
come on down, Sunday.
Anyway, and it's got this nice looking. I haven't used it, but I watched a video of it. The video's terrible. It's got one of those computer voiceover. Sounds almost like a computer voiceover thing. It's awful.
Really? Oh.
Yeah, I hate those. And but anyway, it's a nice graphical user interface. So none of this, VHDL Verilog rubbish, right? It's a nice little graphical interface where you drag and drop a little lookup table and a flip flop and a.
Yeah, because this is low gate count, right?
It's small enough where you don't want to dick around with Verilog and VHDL. You just it's only got I don't know how many gates, but it might have 10 flip flops in it or something.
Yeah.
So
that would be cool is if you saw someone who put a bunch of these together and basically built up a full scale FPG. Now, granted, it would be like the size of a pizza,
right.
but I mean,
yeah,
that'd be funny. I mean, it sounds like a cool idea though. I mean, like a nice little toolbox chip.
It looks really nice. Yeah, I would prefer to design my chips like this. I know exactly what I'm getting. I've got a visual representation of what my internal circuit of that chip is. I love it.
You're just afraid of Verilog and VHDL, aren't you?
Yeah, I am. Give me a schematic any day.
No, that's horrible.
But there's no schematic.
It's not practical these days. Most time,
if you're doing
people are using FPGAs these
stuff.
days. Yeah, you need to be in CPLD land or below. That's what you need.
Yeah, exactly. So, and that's what this is. It's almost a CPU. It's basically a CPLD.
It's like a tiny one,
with an FPGA architecture, but a CPLD density level kind
of
thing. Third catch, folks. I'm glad you asked because I know you sniffed bullshit.
Yeah.
Okay. Third catch is
there's more.
It's only available in a 2mm by 2mm. What is it?
One
leadless grid array package.
Oh yeah, the one where there's like a 90-degree metal angle on the it's a 90-degree angle around the sides.
Leadless ceramic.
Yeah. So you can solder it down and then you can probe it, but you're probably going to be.
And it's got a thermal pad on the bottom. There's one device with a thermal pad. So anyway, that's one. So it's not like you can go buy it in a DIP 8. If you could get it in a DIP 8, this thing would be a hell of a lot more popular at the hobbyist level. But I guess they don't care, right?
No, they don't give a crap. Not at 23 million.
Why are they selling 100 of lots? They got like an online shopping cart where you can buy 100 chips. See,
what you need is I mean, you could do a easy breakout board for that though. I mean,
of course,
SparkFun or someone like that would probably do one. So I don't think it's that big a deal.
Oh, it's not, but it's nobody wants that. They want the actual chip.
I wonder if they're even making. I mean, they must be, right? But you got to figure that the people who are selling DIP leads, they pour the actual package type, right, with the type of material it is. But the leads itself, I mean, those have to be in lower demand than they were, right?
Yeah.
Unless people are just manufacturing their own.
There's a whole bunch of people sitting out there. Damn, I wish we could churn out more DIP 8.
No, I don't think that at all. But I mean, it seems like the whole the architecture for doing it is kind of not the architecture, but the system for making these parts, and it's just going away because there's no demand for it, or there is, but it's very small demand.
Right.
Yeah. Instead, they want 1 by 1 by a half millimeter parts, right?
Yeah, exactly. That's what everyone wants. So
and
fourth catch.
Right? Wow.
Fourth catch, is that, as you can probably imagine, it's not leading edge performance in any way, shape, or I think it's quite low power. It's probably got that advantage, but in terms of, as I said, there's analog functionality in there, and it's pretty shit looking analog functionality.
Of course,
right?
It's
not precision, as we've talked about, right?
Yeah, I mean, people, if you're thinking about this part, it's meant to go into a smoke detector or
Yeah,
a thermostat.
exactly.
It does not care
Yep.
if you need
If
18
your noise
bits.
floor is
Yeah, exactly.
one bit or 10 bits,
Right, exactly.
Yeah. So anyway, it's rather novel because there's nothing else out there like it. So it wins in its novelness, I guess.
So
and
is
the
this-
fact that it's so cheap. I mean, that is just jelly bean stuff.
Yeah.
It's
So
crazy.
is this an unofficial chip of the week? I mean,
It's probably a chip of the week. Yep.
I don't think it's on that other site yet. I don't think it's on the Reddit site. So
There you go.
yeah.
We found it first.
Yep.
Always listen to the amp hour before Reddit.
There you go. You heard it here. All right.
And fifth catch.
Oh
right?
God.
Yeah.
This is worse than
I haven't
the
checked on this.
Scope
I'm going
Baby.
by hearsay.
Yeah.
Is that the programming interface is not open, so you have to use their programming tool and their software and everything else. I think.
Yeah,
so,
but it's not like there's code either. You're doing you're
No.
using a proprietary, unless they allow you
chip
to
anyway.
use code.
Yeah, exactly. So it's not a huge deal, but technically, if you wanted to build your own programmer,
Here's a real question: is it the 23 gigabyte install that Xilinx wanted to put on my computer?
Right.
Because if it is, if
I
it
don't know, I
isn't,
haven't downloaded
plus
the
one.
package.
Oh my God! Xilinx.
Yeah,
I love Xilinx parts and I love
They're
Altera
all the
parts,
same.
but
They're all the same.
it's unbelievable. That's
I
too
know.
big. That is too
See,
big.
and you love FPGAs, right? And you want people to use these shit. They're bloody. Give
I
me a
love
break.
No, it's the problem is they support everything. They don't selectively support like one board. The thing is they'll have one development board, right? And that will need 400 megabytes in support files, and then they support like 30 different boards in one install, and so there's just gobs and gobs and gobs of code. It's unbelievable. They should do it on a per basis. And
Well, it's not just the support for the chips, it's support for all the other, if you want power analyzers, timing analyzers, it's all in there. If you just want to write a bit of VHDL or Verilog and program your chip, that's it. Thank you, ma'am.
I don't know. Looking through directories, it seems like it's mostly the board support stuff because
Right, okay.
I mean the power analyzers these days they're still spreadsheets. I mean it's like that's not a big deal.
Yeah, they do a lot of that, but there's so much that these packages can do. It's just ridiculous.
Yeah, I agree. It's all in one, and I need more of a cafeteria style. Even though stupid consumer might not know what he needs.
Right.
If you make it easy, if it's integrated with the web, it should be relatively easy to download. But the thing is, it's not a big deal to them because they just you don't have a choice.
Yeah.
So, yeah,
Tough tits.
tough. Yeah, tough indeed.
That's the price you pay for FPGA development, really.
Yeah. And speaking of programming, so did you see about the co-inventor of C?
Yes,
Dennis Ritchie.
Dennis Ritchie. Yes, everyone who's ever studied C has a copy of his book, along with Kerrigan. Kerrigan and Ritchie, isn't it? Are the authors of the
his
C,
co-author. Yeah.
Yeah. Is the co-author of the standard C book.
Yeah.
And but he's a lot of people don't know he was the father of Unix, one of the fathers of Unix as well. So
Yeah. And I mean, Wired has a great article. Basically, we didn't really mention it last week about Steve Jobs dying, but Steve Jobs wouldn't have had Apple without Unix and C. I mean, like it's just everywhere. I mean, you don't even realize it. It's just everywhere. Everything low level, everything. Like it's just it's too bad. I mean, I think he was sick for quite a long while, Dennis Ritchie.
Right.
But it's just kind of giants of technology kind of passing away. So it's too bad.
Yeah, well, it's bound to happen, right? Given enough time.
Apparently, time marches on. I've heard about this.
Yeah, it's a bitch. Yeah.
Luckily, I will be frozen in my basement,
Right.
like Encino Man or something like that. Right.
We'll thaw right. And when the world's in grave danger, we thaw out Chris Gamble to save the world.
And then he starts complaining how cold it is. Yeah.
Right. Austin Powers style.
Yeah.
Oh boy.
Yeah.
Let's not go there.
Yeah. There's a couple other interesting bits of information about Dennis Ritchie that I didn't realize. I mean, I knew about the Unix thing. I knew about the C thing. he won the Turing Award. He won the National Medal of Technology.
Yeah.
And those are to be expected. I'm sure he'll get even more recognition posthumously. But there was another fact in here. I should have wrote it down. There's something else in here that was pretty crazy. I mean, there's a big picture of him on a PDP-11. It's pretty crazy, but
I've seen something in this list which I just noticed, and I must talk about it.
Are we skipping away now?
We're skipping away. Sorry.
Well, rest in peace, Dennis Ritchie.
Dennis Ritchie. Yes.
Yeah. All right, Dave. What was so important that you took away from the tribute to a great man?
The University
it's
of Minnesota. It's
going to look really bad now.
Yeah, exactly.
Speaking of, what are you going to talk about?
He may have been in this camp. Here we go.
You might be in this camp after this segue. We'll see.
Right. We'll see. The unit you put this on here, right? So I'm going. This is from my friend who's a buyer. He's a purchasing agent, and he loves explaining the differences between engineers to me. So he sent this to me. The University of Minnesota has a program to help socially awkward engineering students. What the? Isn't that every one of them?
Not me, Dave. What about you? Were you an awkward?
Bloody oath I was. See, you're not a real engineer because you're not socially awkward.
Oh, well. I'm pretty socially awkward, let's be honest here. Not as awkward as going away from the tribute to the inventor of C to talk about nerds, but so what's going on with this? We're trying to talk
about him the whole show.
Yeah, I know.
He was cool. He's gone. Rest in peace.
So what do they teach? There's 11 classes, right?
I don't know. You're telling the story. You put it on here. You tell us.
This is from
there's 11 free classes. Hang on.
This is from last week, two or 3 weeks ago. Yeah. Basically, let's see. They learn leadership, personal networking, navigating office politics, teamwork, and understanding generational differences. Wow.
Oh wow! What?
Yeah, I can imagine navigating office politics. And now, what we're going to do is stand behind your partner and stab him in the back.
And here's how you design an early warning boss detection system for your cubicle.
Yeah.
I mean, come on. That would be funny. Office politics would be. I'd love to teach that. That would be freaking hilarious. Oh, that would be great.
Oh yeah. I don't really play in office politics if I can. I try and avoid that. But.
Oh, see, I don't play it. I laugh at them and insult them and tell them to piss off and all sorts of things. That's why I never got promoted. Okay. I'm not leadership material, apparently. So,
gotcha.
Yeah. See, number one rule of office politics is don't speak your mind.
Yeah, you're bad at that.
Yeah, I'm not doing too well. Maybe I need to go to the University of Minnesota and learn this stuff.
Another person who's bad at this kind of stuff, Bob Weidlar. We've talked about him in the past before. He was kind of a brash character at National, right?
As evidenced by his famous photo of him flipping the bird.
Right, exactly. And so I was looking through some of the people coming in, I was looking up that photo and how people search for it now, because that's how some people are finding the amp hour these days. Pretty cool, right? And so I go and search for other pictures of Bob Weidlar, and I go onto the Computer History Museum site, which we talked about last week, and there's this picture of him on there, and it's a picture of him in front of a blackboard with, you could see like wells and junctions and everything on silicon drawn there, and it says, "Digital circuits, I'd rather fight than switch," and he's holding a friggin' axe.
Oh yeah, that's great.
It's amazing.
That's a fairly young Bob, because he hasn't got the grey hair there.
Yeah. And this is it's taken by Fran Hoffert, who took the other picture as well. And,
right, okay.
Yeah, it's awesome.
That's great.
Yeah, it's a great picture.
Fight and switch.
Yeah.
Oh, it's brilliant.
Yeah, this is just more ammo in the chamber to go to the Computer History Museum. There's a whole section on analog computing that you can look through online. It's really cool. And
you've got to physically go there. It's great.
Yeah. There's one picture at the end of this analog computing thing that I'll link in, but it's just it shows like and they're doing like transistor based stuff, and I think some of that even before that was like mechanical based stuff, and but like point to point wiring on the transistor based stuff and triodes and pentodes and all that other like all the tube stuff. It's just crazy pictures, It's like, man, they used to use this for calculations. It's like they weren't joking around there.
No. So
yes.
anyone who hasn't been there, seriously, make the pilgrimage. Go on a road trip by way of all the surplus stores and end up at the Computer History Museum.
Yeah, definitely.
That'd be great. What if you got a bus?
A nerd bus?
You went on a nerd bus and you went on a nerd road trip. What stuff would you include on the nerd road trip? Well, obviously the HP garage, right? Given.
Yeah, you'd start there. You can go north. I mean, you're talking about even just sticking around Silicon Valley area or getting out of Silicon Valley eventually?
No, get out of Silicon Valley. It's a road trip, dude.
Oh, well, I would definitely go over Hoover Dam. I mean, I love the Hoover Dam.
Yeah, it's pretty cool. I've been to Hoover Dam.
A nerdy marvel. You could go north, I guess. Go up through Northern California. I don't know where you'd stop up there.
I don't know. If you've got any good ideas about what we could include on a nerd road trip.
Nerd road trip, huh? That's like the nerd cruise. We had that on here from a long time ago.
Yeah, that's right. Yeah,
that's a little bit different,
that wasn't
though.
Electronics nerds, right? That was like computer nerds.
Yeah, that was. That was like they actually rent a boat and I guess they give talks, and it's kind of like I think it's like a DEF CON style, like where they actually have like
lectures and papers and things. And
God, that's got to be a gross pool scene. No offense, people. That's just a lot of lot of pastiness like me. If I'm sitting around a pool, you do not want to walk by. Dave's a fit dude. I not so much. I don't get outside much, so.
And there is that stereotypical difference between a computer nerd and an electronics nerd. As in, well, the computer nerds are more geek, right? So they're stereotypically like fatter, overweight, right?
Well, I don't think we want to get into this.
Nerds are rather, sickly, thin, gangly kinda.
I think it could go either way,
white,
really. I don't want to be divisive amongst our nerdy brethren here. I am inclusive of all great nerds. I love all my nerdy brethren. It's nothing like a good
nerd fight. Come on.
Oh, come on. I don't want to get into a nerd fight with people. We were talking about cars before. If someone hacks a car, they can mess you up, man.
Right.
And to be honest, I mean, this stuff is all converging too. I mean, it's interesting seeing, like, at least in the hobbyist scene, like a significant number of people that are getting interested in electronics seem to be IT type personnel. I mean, maybe it's just because of sheer numbers, but there are a lot of IT people out there, but it seems like there's a lot of great interest from them, and hell yeah. So, I mean, immediately then you got some crossover nerd there,
Yeah, but ultimately they would rather spend their night installing a new version of Ubuntu Linux or something than they would, stoking up the soldering iron and sucking some fumes.
Sucking some fumes, huh?
Yeah, that's right.
Okay.
Or searching DigiKey or something like that. So,
right, yeah.
Yeah, they're a different type of... Yeah, they're more geeks than nerds.
Okay, well, we'll have to send them... Maybe we can have a nerd school or a geek school, as well as a socially awkward how to go through office politics kind of school.
Right. And we'll have to talk about it next week on the Amp Hour, because our Amp Hour's up.
Oh, yeah, that's way up, huh?
Yeah.
Yeah.
We missed a lot. Dude.
Yeah, sorry. Next week. All right.
All right.
Well, we will see you all next week, and thank you for listening.
Bye.
Anyway, college is a whole new ballgame. People judge you differently than they did in high school. Where are they? I think they're They're talking about us. No way.
Oh, nerds! 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 Nerds!
Come on, Lewis, let's go.
Nerds! 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 Nerds!